Hello and welcome to the January webinar from the IEA Clean Coal Centre. My name is Paul Ruya and I'm Northland Analyst at the Centre. Monthly webinars are based on our technical reports which are available from our website www.iea-coal.org. Residents of member countries and employees of sponsoring organisations can download our reports at no charge after a one-off registration, so please visit our websites for details. Today I'm presenting a webinar on the global forest resource for power generation fuels, chiefly to look at fuels used for co-firing in coal-fired power stations. My reports will be out in draft in coming weeks and the final will be published soon thereafter. If you have any questions during the talk, please use the Ask a Question box at the top of your screen and add your email address so that we can send you a fuller answer if you require one, and also if we run out of time. Fossil fuel resources are published regularly. We see the BP Statistical Review publishes every year. We also see the World Energy Council, the German Federal Institute for Geosciences and Natural Resources, and World Resource Institutes also publish similar documents, but only some include biomass in any detail. Yet biomass is a significant contributor to the world primary energy demand. It's the fourth largest supplier of energy and the fifth largest contributor to power generation worldwide. Biomass accounts for 10% of world primary energy demand at 56 exajoules, 3 times the contribution of all other forms of renewable energy combined, quite a staggering statistic. Biomass should therefore be treated more widely as a conventional resource, rather like fossil fuels, provided the resource is of course assessed on a sustainable basis. Much of the demand comes from heating and cooking in non-OECD countries such as Africa and Asia. Elsewhere in Europe, renewable biomass is playing a crucial role in reducing greenhouse gas emissions in some fossil fuel stations. Today's modern biomass market is going beyond the traditional local market of subsistence economies and now involving the international trade of wood pellets between major power companies in Denmark, Sweden, Germany and the UK, trading with biomass suppliers in North America and the Baltic states. The wood pellet market has developed into a 22 to 25 million tonne per year market with the help of long-term contracts, but a spot market has also emerged. More trade journals are regularly publishing and reporting volumes, price indices and freight rates for seaborne traded pellets. Markets have therefore seen a rapid development of price reporting and price transparency, particularly for large commercial contracts. Biomass pellets, in fact, is now equivalent to 10% of the world grain export market. In fact, this slide shows a small sample of Indonesian export coals from one of the country's largest producers, Adaro. Now, if we look at the Enviro Coal 4000 product I've highlighted here, the moisture content is 38% as received and 20% air-dried. And at these levels, they're not too dissimilar to some wood chips and wood pellet products. And so, therefore, wood pellets are therefore comparable with products from the world's foremost exporter of steam coal. Modern biomass pellets are therefore highly competitive qualities, even with some steam coals, although pellets are generally priced at more than double that of coal, currently around $180 per tonne versus $70 per tonne delivered into northern Europe at the current scales of production. This slide is based on a graphic by Poiri published in 2009 and provides a trajectory for pellet demand worldwide in millions of tonnes for the years 2010, 2015 and 2020 for various regions of the world. When aggregated, the total global demand was estimated to be about 15 million tonnes in 2010, and it was expected to grow to 28 million tonnes in 2015, which is actually a pretty good estimate. It's probably within 10% of the actual trade that we've seen in 2014, 2013, and possibly reach 46 million tonnes by 2020. In the past, a great deal of the demand was from dedicated heating boilers, such as residential and district heating boilers and small power generators in Northern Europe and Scandinavia. But in more recent years, we're seeing pellet demand has been boosted massively by co-firing in current or former coal-fired power stations in countries such as the UK, Netherlands and Belgium. And 100% biomass conversions are occurring also in Denmark and in some units working alongside coal-fired stations such as Drax in the UK. And they are either complete or nearing completion. So what is the global potential demand for biomass from the world's power generation fleet? Well, currently there's only about 60 gigawatts, 60,000 megawatts of dedicated plants that are burning just biomass at the moment. When we look at the coal-fired fleet, however, it is significantly bigger, and unsurprisingly, at 1,848 gigawatts. 36, which are already reported to be capable of co-firing or at least using biomass as an alternative fuel. Early retirements of coal plants in the OECD could see this level drop to about 1,645 gigawatts by the year 2020. That's net, including additional plants that are currently under construction in the Far East. A low co-firing rates of, say, 5% could mean a target market of potentially 82 gigawatts of coal-fired power stations that could be burning biomass. This roughly equates to roughly 235 million tonnes per year of biomass, equivalent to about 4 exajoules. Therefore, the current pellet market could expand tenfold, and also, in doing so, saving 400 million tonnes of CO2. Of course, co-firing at higher rates of 10 or even up to 15% could increase the opportunities for biomass even more. So given the potential increase in co-firing in the world's coal fleets, is there enough biomass in the world to accommodate the market? Well, the rest of this talk will look at some of the findings we've come up with. We focus on the main sources of biomass pellets. They are wood and straw, but other biomasses do exist, we do recognise that, but they're not covered in this talk or in the report. In order to avoid any complications with conflicting biomass resources and other land uses, we avoid looking at any energy crops or resources that derive from the entire tree or plant, so we only assume that biomass resources for co-firing with coal are from residue, from other economic activities such as timber production and straw from food crops. Now, this is a chart that shows us a wide range of biomass potential based on a series of already published reports, and a vast amount of resource is clearly estimated for energy crops, which are the points you can see on the left of the chart. There's a huge potential for total energy crops of between 20 to 1,200 exajoules per year, a great deal of which can be grown on surplus agricultural land. But assuming there is a potential conflict with the plethora of biodiesels and biogasoline crops, we will avoid this in our analysis. So we'll certainly look at certainly an area that we could look at in the future in our company, but for now we'll just look at residues. Now, the potential resource derived from residues from forestry and agriculture is much smaller, perhaps around 50 exajoules per year, which I calculate at roughly 2,900 million tonnes per year of wood pellet equivalent. And short rotation forestry in the very far right can also offer more fuel for the biomass market. Now, current pellet production, we said, was around 25 million tonnes per year, so there's plenty of opportunity for a much bigger pellet market, provided the correct financial and regulatory incentives exist and promote biomass co-firing around the world. Note we're constantly changing between exajoules and tonnes, and this can be quite confusing. Most of the studies, in fact all of the studies that look at the global resource for biomass, nearly always express biomass in exajoules for convenience and to standardise all the different biomasses. But presenting data in exajoules is also very difficult to visualise. So what do these resource terms mean in terms of the units of measurements that perhaps suppliers and traders of biomass are more familiar with? And for instance, mass in tonnes or hectares of forest or even cubic metres of roundwood production. So what we do is we use a simple bottom-up approach to try and estimate the amount of biomass stock in mass terms that resides around the world, as well as the potential residue that exists under current production levels for both forestry and crop production. Our primary data source is the UN Forestry and Agriculture Organization, which offers a wealth of data on forest biomass, carbon stock, volumes of industrial roundwood production, forest area that is designated for all different purposes, as well as crop production data for most countries around the world. This slide shows the global land area of 13 gigahectares in total, so that's 13,000 million hectares of land. 4 gigahectares of this is covered in forest, and this is the green section, and you can see it's spread broadly across most of the continents, chiefly in Europe and Latin America, as you can see. 1.5 gigahectares is used for arable crop production, and the arable is just the yellow section. And quite a considerable amount is used for livestock, cattle and dairy farming for pasture land, which is 3.5 gigahectares, which is the blue section. The grey squares on the right also illustrate the land area for a few countries, just for comparison. Now, this map shows the geographical spread of forest area, and there's an abundance in the temperate and tropical latitudes, while much of Africa and Middle East and Australia is unsurprisingly practically barren in terms of forest as a percentage of their total land area. Russia has the largest land area covered by forest, almost half as much as Brazil, but Brazil has a much larger stock of biomass than Russia, and we shall see that in some of the data later. It'll be maybe no surprise to many of you familiar with forest statistics, so this is where we would expect to see most of the forest. This pie chart shows the top 10 countries with the largest forested areas, so here we've got Russia and Brazil at the top. As the previous slide suggests, Russia has the largest at 809 megahectares, and Brazil is second with 520 megahectares. But if we were to show the top 10 most biomass-rich countries, Brazil would be in first place, since all the tropical countries would probably move up a place or two due to the density of biomass per hectare of forest, providing considerably more mass and considerably more than the temperate forests. Now, to determine a global resource, we took a series of logical steps to determine the stock of residue that exists both in the total working forest, and the residue that can be supplied from the current level of industrial roundwood production. Now, when I mean global, we took a sample of 21 countries where the FAO had all the relevant data that I needed for the analysis. And we had enough countries to cover at least 2/3 of the world's forest stock. Now, one of the most crucial inputs is understanding how much of the forest cannot be used, and how much is officially designated for industrial roundwood production, the first part of the supply chain before wood becomes processed for timber products or pulp. The global average suggests that 30% of the world's forest is designated for production. The rest, however, is protected for a variety of reasons, whether it's soil and water protection, conservation of biodiversity, and social services and community services. Huge resources exist in most regions, but the percentage of productive forest is illustrated in the map on the right for some sample countries published by the FAO. Not on the map, however, are some countries such as Australia and Canada, which, according to the data, only have officially 1% of their total national forest designated for productive use. In Finland, however, 90% of the forest is designated for production. It seems a bit curious because Canada has a huge forest industry, so apparently the low percentage in Canada seem contrary to the vast amount of industrial production that they have there. But the reason for that is the majority of the forest in Canada is designated for multiple use. This then incorporates a range of forest management activities such as wood production, use of forest as watersheds, grazing by domestic livestock, and forest for habitats for wild game and fishing, and other outdoor recreation. So because there was no clear demarcation of wood production in Canada, the estimates for Canada are grossly underestimated, simply because we don't have the firm data yet. Now, the forest mass in million tonnes is established for productive forest using FAO data, but we must now make an estimate of how much of this forest is residue, and you try and establish what percentage of the forest biomass can be used for co-firing. Remember, we don't want to use the whole tree unless it's available by other means, such as from localised forest clearance for forest fire prevention measures. So how much residue could be technically available for collection and reuse as a heat-raising fuel? Well, if we just look down the list, 23% of the tree, which is the top branch and foliage, which is normally called the crown of the tree, can be collected and chipped. A further 10% can be large stumps, which also can be sawn and chipped. 5% of the forest residue can be sawdust on the forest floor, but that would normally be left as nutritious soil mulch, so we leave that out of the calculation. As we do in sawmilling, the amount of products are used for slabs, edging and offcuts, which are used for roughwood products, which account for 17%. Sawdust and fines can add 7.5% to our residue total, normally collected at the mill and much easier to collect here than the forest floor because it's collected in a controlled environment. Various losses, of course, will be deducted. 5.5% of bark can be reused and is used today as a sort of coarse drying fuel, particularly through for wood pelletizing, the wood pelletizing process. And of course, we don't include the primary product, which is 28% of the tree, which is sawn timber for the end user wood products. And no roots are left in the ground for soil stability reasons, so anything below ground is left out of the equation. This gives us a net residue of 46% of the tree above ground is potentially residue for pelletizing material or heat raising material. Now, using the various assumptions described in the previous slides, we arrived at an approximation of the residue stock of the world's producing forests. And Russia, you can see here, stands out by far as having potentially the greatest residue resource of roughly 5,700 megatons, with Indonesia, USA, Brazil and China also holding vast amounts of forest designated for industrial production at around half or less of that of Russia. The result of this simple analysis gives us a residue resource of 14,220 million tonnes, which is equivalent roughly to 177 exajoules. So this is covering the 21 sample countries that we had data for. This resource assessment gives the total in situ stock of wood, but rather like looking at the estimates for coal, oil and gas resources that determine the entire resource that is known to exist in the ground. A different way of assessing biomass resources is more in common with looking at renewable energies is to look at the supply potential on an annual basis. And this is what we do next. By repeating the methodology on annual roundwood production data, in this case we took 2013 production levels, we can attain an annual supply potential for wood residues. The results show that the world industrial wood production can feasibly supply 714 million tonnes of wood residue per year, which is equivalent to about 9 exajoules. Now, when we compare this with the wood pellet market of roughly 25 million tonnes, there appears to be a massive potential for wood residue from current forest activity. Our figures for cofiring earlier in the presentation suggest that the world's coal-fired fleets could demand around 235 million tonnes per year at a 5% cofiring rate. So again, this is well within the current residue resource that could be available every year. Most of the world's industrial roundwood production is in the USA, Russia, Brazil and China in that order, while the world's coal-fired stations are in fact in non-OECD Asia. And so I'll let you draw your own conclusions on what potentially could happen regarding international trade in this commodity. But for now, the trends, according to the POIRI graphic I showed earlier, suggest that wood pellet trade will remain between supplies from North America and demand in Europe. We also look briefly at agricultural residues, chiefly annual straw production from global cereal crops. Straw has quite a good heating value. Some straws have heating values not too dissimilar to wood chips, albeit with some variations depending on whether the straw is either in yellow form or grey. World cereal production is estimated to be about 2,500 million tonnes per year, so therefore the residue potential is indeed immense. Straw resources are more complicated to consider, however, as straw has multiple uses and could conflict with the need for bedding for livestock and as an organic nutrient for soil. Land use change in agricultural land is also arguably one of the biggest unknowns and variables for the future crop of cereal crops. Land for crop production could be doubled if unused pasture land was adapted for arable farming. As such, we only assume just a quarter of the straw residue is available for co-firing. Other non-cereal residues include tropical crops such as palm oil, which is particularly abundant in Indonesia and Malaysia. Malaysia has investigated co-firing palm oil biomass with coal at a very small scale, and there's still plenty of scope there. Production in Malaysia alone is 17 million tonnes per year. Indonesia is roughly about 28 million tonnes. Only 21% of the harvest of palm oil is actually used for the oil product. The remaining 80% is potentially residues. So palm oil is not only valuable oil commodity, it's also potentially an incredibly valuable biomass commodity too. Finally, to conclude, with the overall resource as estimated using a simple method of looking at forestry and agricultural production of wood and crops, we looked at area, we've looked at tonnage, we've looked at the percentage residues, and using a simple residue function from all of this, we come up with a potential supply resource of roughly 8.9 exajoules per year for wood, which is equivalent to about 700 million tonnes a year of biomass pellet equivalent. For straw, we have a potential resource of 5.4 exajoules per year, roughly equivalent to 430 million tonnes in terms of pellet equivalents. Now, these figures will differ from other assessments due to the consideration that we're looking at residues only, and we only use production for the year 2013. When you look at most other published data, they look at projected biomass supplies and consider future harvest yields, future land use, and the need to meet higher demand for both renewable energy and higher crop outputs for a growing global population. In addition to that, we have, as I mentioned earlier, energy crops, waste from municipal sources, as well as biomass from industrial waste processing, which all add considerably more to the global biomass resource base, and will also require further research. Thank you for listening. I shall now take any questions from our audience, and I think we have plenty of time for questions. We have 3 questions. First question: what can a power station feasibly co-fire without needing major modification, and of course which will have implications for the demand on resources? Well, the IEA Clean Coal Centre has done a great deal of research in this area, and arguably 5% is the sort of injection rates that you would get for testing and trial purposes to see how the power station fuel, biomass fuel, can behave in the boiler. However, it's arguable that some biomasses can be injected up to, if you like, effectively a concentration of 15%. Above this, the power station boiler and systems require significant investment to adapt to much higher percentages. But 15% is more or less the upper limit. Now, when we look at wet or dry tonnes, generally I'm looking at dry tonnes. That's the second question. So I try to basically assume a heating value of between 15 and 17 megajoules per kilogram for pelletized wood, and assume I converted all the exajoules to like a pelletized wood equivalent, which is generally a much drier product. And I've got a third question. I have no sound. I'm sorry for that technical problem. I hope, well, if there's any other feedback in terms of the technical side of things, we would appreciate that, and so we can investigate for future webinars. And I'll just wait a couple more seconds for any more questions. In the meantime, thank you for listening. The next webinar is on climate implications of coal to gas substitution in power generation by my colleague Herman A. Nalbandian. That will be on Wednesday, the 18th of February. I've got another question. Will we share our slides? Yes, the slides are always available. In fact, we have a back catalogue of all of our webinars if you're interested. And by all means, you can access this presentation at any time. I'll just wait a few more seconds in case we get any more. And I'll just put you onto the slide for our member countries. Another question has come in. What gives you the confidence to assume that all the potential is available for the energy sector and for co-firing in particular. Some of those residues are already used by other sectors. No, I do not have 100% confidence, I'll be honest with you. What we've done, or what I've done here, is to look at biomass resource as though it were a fossil fuel, and so exactly the same argument would apply to oil, gas and coal resources. The various markets for those various commodities. Usually when you look at resource figures, they only give you a single resource figure, but really the end user demand isn't discussed. Really the purpose of this report was to see how much resource there was out there potentially and see if it could supply future co-firing. If you look back at the data I presented, in fact the co-firing demand is way below the actual resource level, so there is plenty of scope for demand from other sectors there. So I think the resources are abundant enough. All right, we have a very interesting comment here. I mentioned that 15% of co-firing was a maximum, and that's our respondent here states that this might apply for wood pellets, but torrefied pellets, which is effectively a wood pellet that's undergone reduction and effectively is a much more greater energy dense product, as you're already aware, the co-firing rates can be much higher. That's assuming much higher and not requiring any further adaptation or considerable investment to the power station. The respondent didn't give me a figure as to what that rate is, but clearly 15% is the old maximum. There clearly is a new maximum for torrefied pellets, and perhaps that's something, an area for future resource for the Clean Coal Centre. Well, I think that's it. Thank you so much for listening. Thanks so much for the feedback. Really appreciate you joining me for this, and we shall hopefully please tune in again on Wednesday the 18th of February for our next webinar. I shall now end the webcast, and thank you all so much. Cheerio.